Okay, so now we are going to discuss about the simultaneous equation method for estimation for estimation of for estimation of ibuprofen and paracetamol by UV spectrometry. UV spectroscopy, spectrometry, all these things are there. So now before moving toward the simultaneous equation methods, let's have an idea about the simultaneous equation method. So what is simultaneous equation method? It is a classical spectrophotometric technique. It is a classical spectrophotometric technique. What its use? Its use is to use क्या है इसका? Use to analyze mixtures of two components. Okay, are you getting what I am saying? Without prior separation. Now this method, simultaneous equation method, is based on Beard-Lambert law. Are you getting what I am saying? So basically these are the things. Okay, now for a binary mixture, example we are taking of ibuprofen and paracetamol. Okay, so both components what they do, they absorb UV light. They absorb the UV light at two selected wavelengths where their absorbances differ significantly, and if we assume that both drugs obey Beard's law, not Lambert's law, Beard's law at these wavelength, then their concentrations can be calculated. Now again, the thing what we have to study is the Beard's-Lambert's law. We all know A is equivalent to epsilon C into L, where A is the absorbance. This epsilon stands for molar absorptivity. What is the expression for molar absorptivity? It is mole liter mole inverse centimeter inverse. Okay, so this is the expression for molar absorptivity. Okay, now this concentration is in moles per liter. Okay, and L, the path length, is in centimeter. Usually it is 1 centimeter for standard cuvettes. Why it is called as 1 centimeter? Because it is the 1 centimeter mentioned for standard cuvettes. Now keep in mind, these cuvettes are made up of the quartz crystal, which has to be kept in the UV visible spectrophotometer. Now let A1 and A2 be the absorbances of mixture at lambda 1 and lambda 2. Okay. Now thereafter this epsilon I1 and epsilon I2 are nothing but the molar absorptivity of ibuprofen at wavelength lambda 1 and lambda 2. Okay. Now thereafter epsilon P1 and epsilon P2 is the molar absorptivity of paracetamol at lambda 1 and lambda 2. Now we will frame the equation for solving the laboratory practicals. So we are considering two equations are constructed based upon the fact that lambda 1 and lambda 2 are the absorbance of the mixture, and which is the sum of the individual absorbance of what? Drug X and Y. X is the ibuprofen, Y is the paracetamol. So at lambda 1 wavelength, let A1 is equivalent to AX1 BCX, AY1 BCY. Simple mathematics equation, simultaneous equation. Okay. And at lambda 2 second wavelength, A2 would be AX2 BCX, AY2 BCY. This is the second equation. Okay. Now we know the path length is of 1 centimeter, so B would be 1. So now I am going to rearrange the cells. So Cy is equivalent to A2 AX2 CX, okay, AY2. Are you getting what I am saying? So these are the equations. Okay. Now what I am doing basically, so now basically I am substituting Cy in equation 1 and thereabout rearranging, that gives the final equation, that is Cx is equivalent to A2 AY1 minus A1 AY2. Okay. Thereafter AX2 AY1 minus AX1 AY2. So this is the equation for Cx. Okay. And Cy equation, Cx means the concentration of the X drug, Cy is the concentration of the Y drugs. Keep in mind here the X is the ibuprofen, Y is the paracetamol. So A1 AX2 A2 AX1 AX2 AY1 AX1 AY2. So this is the criteria. Now what are the criteria? Let's see. I hope this is clear to all of you. Okay. So now what are the criterias? Let's see. What are the criteria for simultaneous equation? Okay. So the two components do not interact chemically. The two drugs, second thing, the two drugs shows absorbance on each other lambda max maximum wavelength. Okay. Are you getting what I am saying? And lambda max of two components are reasonably dissimilar. Okay. So these things are there. Now we will talk about the procedure. So procedure composed of the thing. First thing is the preparation of standard paracetamol solution. So you have to prepare a solution, okay, which contains 1 mg per ml of paracetamol. That it itself means it is 1000 microgram per ml solution. Agree? So all these things are there. Okay. Now next thing, from the above solution, that means this solution, you have to pipette out. You have to pipette out. How much solution? 1 ml solution. And then what you have to do? You have to dilute up to 10 ml with what? With distilled water. So what the solution, the resulting will be? It would be, the concentration of the solution would be 100 microgram per ml solution. 100 microgram per ml solution. Now from this solution, 100 microgram per solution, from this solution, that means the 100 microgram per ml solution, you have to pipette out 1 ml solution and then dilute it up to 10 ml with distilled water. So the resulting concentration would be 10 microgram per ml. 10 microgram per ml. Okay. So these things are there. Now what you have to do? You have to measure the absorbance of the solution at lambda 1 and lambda 2. So what is lambda 1? That is for paracetamol. Lambda 2 is for ibuprofen. All these things are there. Now furthermore, now you have to prepare standard solution of what? Ibuprofen. So how you are going to prepare the standard solution of the ibuprofen? It is prepared through a solution which contains how much? 1 mg per ml of ibuprofen. From the above solution, what you have to do? You have to pipette out 1 ml solution, and then what you have to do? You have to dilute up to 10 ml with distilled water. So what you will get? You will get a 100 microgram per ml solution. Now from this 100 microgram solution, you have to pipette out 1 ml. Okay, and then you have to dilute up to 10 ml. So that will give the resulting solution as 10 microgram per ml solution. 10 microgram per ml solution. Now after preparation, what you have to do? You have to measure absorbance at specific wavelength lambda 1 and lambda 2. Now what you have to do? You have to prepare sample solution. You have to prepare the sample solution. Okay. So sample solution is prepared with already 100 times diluting the, so it is 100 times diluted. Okay. So that sample solution, you will be provided with the sample solution. From that 100 times diluted sample solution, okay, you have to pipette out 1 ml and dilute it up to 10 ml with distilled water. with distilled water, and then you have what you have to do, you have to measure absorbance at lambda 1 and lambda 2. So these things you have to do. Now thereafter there would be, you have to prepare the observation table. Okay, in that there would be serial number, there would be drug name, there would be wavelength, there would be absorbance, there would be small a, that is called as the absorptivity. Absorptivity is given by A is equivalent to A upon BC. So absorptivity. Okay, so here your drug serial number would be PCM, that would be 10 microgram per ml. Okay, your resultant wavelength would be there, scanning wavelength would be 242, 222. Okay, and you will find out the absorbances, and thereafter you will find out the AX1 and AX2. You will find out the AX1 and AX2. Similarly for the ibuprofen, okay, you will take 10 microgram per ml of the solution. You will use the scanning wavelength 242 for lambda 1, 222 for that lambda 2 nanometers. Obviously you will find out the absorbances, and then you will find out the AY1 and AY2. Okay, so all these things are there, means absorbance multiplied by the Y1, absorbance multiplied by the Y2. Okay, third thing would be sample, lambda 1 again, lambda 2. Okay, thereafter you have to find out the absorbance A1 and A2. Okay, all these things are there. Yes, now Beard's-Lambert law, A is equivalent to ABC. Okay, A, epsilon, don't get confused, these are the molar absorptivity. So molar absorptivity is equivalent to A upon BC. Okay, here AX1 you have to find out. So above would be the absorbance, what you have got, path length would be 1. Okay, are you getting what I am saying? And then the 10 microgram per ml of the solution concentration. So in this way you will find out the AX1, similarly the AX2, thereafter similarly the AY1, similarly by the AY2. Okay, all these things are there. Now you will put up it into the final equation of the concentration. Cx is equivalent to A2 AY1 A1 AY2 AY1 AX2 AX1 AY2, and you will find out the concentration. That concentration would be in mg per ml. Cy A1 AX2 A2 AX1 AX2 AY1 AX1 AY2. Okay, thereafter the concentration would be again, okay, in mg microgram per ml, and thereafter in mg per ml. You have to convert it from microgram per ml to mg per ml. Now thereafter you will report the concentration in the form of results. The result would be as follows. Hear it carefully. Concentration of paracetamol and ibuprofen in the given paracetamol ibuprofen solution by simultaneous equation method was found out to be this much mg per ml, that much mg per ml respectively. Thank you.